Implementation of AstrobiologyxHealthcare. We first envisioned the idea of astrobiology incorporated with healthcare. Then we found investors. Part 3 will talk about the implementation of our project. We will tackle this in 3 parts. The concentration of scientific evidence will be in the last 2 parts. Using investment effectively, collection of samples, and collection of data through samples. First, using investment effectively. We now have funds to kickstart our project. We need to use it sensibly. The rule of thumb is to save 60% and utilize 40% of our investment. 10% of that will be for samples. Note that collections will be done by the government and we are responsible for only transportation. And the other 90% for researchers, testing, equipment, etc. The separate 60% will safely rest in a fixed deposit and we will get a monthly interest. Now, the first thing to check off is sample collection. Second, collection of samples. The collection of samples is the fundamental prerequisite to testing. Before this happens, we need to convince the government to kickstart this. This will normally be done by sending pleas to the mayor's office. Our blood samples will be collected doorstep to doorstep with consent and ethicality. We will ask them to sign a document in case their samples come of further use. To find genetic inheritance, we need a mutual DNA of more than 0.021%. And as research suggests, we all derive DNA traits from the mitochondrial Eve. Eventually, over time, lesser ancestors too developed over many small regions. So practically speaking, 76% of the time, we will have a sample eligible for further testing. The collection of blood will be done in the next tube K3 EDTA non-vacuum blood collection tube. The best sample collector and the most cost-effective. We will store our blood samples in medical fridges. The transportation will happen in pneumatic transport vehicles, planes, trucks, or small connection vans. Once our precious specimens have reached the lab, we can start testing. In medical fridges, the temperature needs to be above 4 degrees Celsius and each refrigerator can hold up to 40,000 labeled samples. Third, collection of data through samples. Blood is an excellent source of DNA. In a study by Genome, it said all diseases have a genetic component. Now, the samples can find genetic hotspot for practically any disease. We have selected cancer, so let's stick to that. First of all, the comparison of blood samples of the civilians will be with the cancer patients. We detect that cancer patients of all types have a RBC count of less than 2 trillion per microliter. Only 20% of all samples will be eligible for this. This 20% will form the foundation of our testing. We will mix and patch samples to find DNA mutuality. After this, we need to find a cancer patient in the near family record. Identify if they were diagnosed with cancer before or after the volunteer's birth, and after this we will be able to detect hotspots and find per capita expectations. We can scale this up to happen at a district, state, or national level. At this stage, we will send our findings to astrobiologists. A large segment of astrobiology is to learn about the Earth's origin, evolution, cell structures, etc. So with this, they will also benefit from the research. Over time, how this happened and even more interesting, can this occur in other planets, will be found out. The next part of our series will look at the ways we can utilize these findings. Thank you for watching a DRO and TGS film. I'm happy to take your questions now.